Hello everyone. Today we are going to show you about Liang-Barsky algorithm. This algorithm is more efficient than Cohen-Sutherland algorithm because in Cohen-Sutherland we make an equation for the area and then equate it with the line. But in Liang-Barsky we just need to find the equation of the line. Uh,
So now we are seeing the Python code for Liang-Barsky algorithm. As you can see here, the boundary region, the acceptance region is defined by using these 4 points, like minimum value of x, maximum value of x, same for y. And then we are using a function clip test, which is used in Liang-Barsky clip, which is our main clipping function. What this function do is it will change the value of umin and umax by checking for the condition. As you know, in Liang-Barsky there are 4 main boundary conditions, so it will check for these and change the value of umin or umax according to that. Also, it will decide if it follows the boundary condition or not. If it doesn't follow the boundary condition, it will simply return false, and the whole function will just return false and will not give any value, because which means the line isn't in the boundary region, acceptance region. So it will check for the p value. If p value is less than 0, it will be an entry point. But if the entry point for the entry point, if the u value is greater than umax, which means the line is not in the region, then it will return false. If it is greater than umin, it will set the value of umin to u. If it is greater than 0, it will be an exit point. If the u value for exit point is less than umin, then it will not be in the region. And if it is lower than umax, it will set the umax to u. If it is 0, as the both conditions is checked, now if the p value is 0, then and q is less than 0, which means the line will be parallel and outside, so it will simply return false.
Now we are going to explain the basic Liang-Barsky clip algorithm. Like x1, x1, y1, x2, y2 are the points of the line. X1, x1, y1 is the starting point, and x2, y2 we can take it as the exit point of the line, end point of the line. This is the clip test in which x1, y1 would be x1, y1. We will take x1 minus x2, which would be minus delta x, x2 minus x1, which would be delta x, y1 minus y2, which is minus delta y, and y2 minus y1, which would be delta y. This would be used for calculating u. From after calculating u min and u max, this u min and u max will only be calculated if x1, x2, x1, y1, x1, y1, and x2, y2.
All the boundary regions are checked, then only it will be calculated as shown in the previous function.
And after the calculation of the u1 and umin and umax, we would be taking out points p1 and p2, which are the clip points of the line which is in the acceptance region. And
And after getting the points which lies on the acceptance region, boundary points, we will plot them. So we are just plotting the our acceptance region, which is just a triangle with min x, min y, and max x, max y. We are setting the color green, as you can see in the output. So this is the region, acceptance region, and this is the function which will plot the first the unclipped line with the color green, and then the clipped line with the color red for illustration purposes.
this is the output which you are getting, in which the circle is the acceptance region, which was explained above as min x, max x, min y, max y. And this is the line with points x1, y1, and this is the point x2, y2. And for example, for this line x1, y1, and x2, y2, and after the clipping test, the points for the line that is clipped is p1, this point, and p2 is this point. The clipped line will be shown in red, and the line which is not in the area would be again left green. For example, this line was full in the area, so it is full red, and this line is green because none of its part was entering into the area.